say thank you to all of our presenters for today. Happy Valentine's Day, and hope your Super Bowl hangovers aren't too heavy and that your team won or at least didn't lose. So we've got a great set of presentations today. Let me just kick off by introducing what Innovations Insights is and about IACMI. Our value proposition centered around the themes of convene, connect, and catalyze, offering a broad value proposition to our members, and including the chance for our members to present what they have to offer the marketplace. A little reminder about our summer members meeting. You should have seen some of this coming out in our newsletter and some other things lately. We'll be in Salt Lake City the last week of June. That'll be just before the 4th of July holiday. So I encourage you to think about building in some vacation time around that and going and seeing some of the great sites that Utah has to offer. But it'll be a full-fledged members meeting. We're doing this in conjunction with the Utah Advanced Materials and Manufacturing Initiative. There'll be some factory tours we're trying to line up, and we can't announce them yet, but they will be pretty special. Big networking reception with hopefully great views of the Salt Lake Valley. We'll have some high-level speakers, and we'll have our working group meetings at that meeting as well. So our 6 working groups will get together, and so that'll all be at the Sheraton Salt Lake City Hotel, and we look forward to seeing our members there. Just the thing about this Innovations Insights webinar is being recorded, and all previous episodes are available on our IACMI website. So if you go to iacmi.org and go to events, Innovation Insights, you can find recordings of each of the webinars that we've done so far. So a little bit about the schedule we have today, February 14th, going forward, March 21st, then April 18th and May 16th. Then we have the members meeting, and then we'll schedule the rest of 22 pretty soon. So be looking out for those. So today we've got 3 great speakers. We'll go from materials to machines to applications. So it's kind of a natural flow from a supply chain standpoint. And our first speaker is Laurie Calligaris. Laurie is the president of Toray Performance Materials Corporation. This is probably a part of Toray you may not be familiar with. And so it's a great opportunity for Laurie to present what they do. They kind of fly a little under the radar when you think of Toray, but they certainly have a big impact. So Laurie, if you want to launch your presentation, I appreciate it.
Yeah, good morning. Thank you, everybody. Thanks for having us. And so let me get our presentation up here. Appreciate being included today. On here. Oh. Just a second, we're having a little glitch here. I think I have to accept your invitation to share. There we go. I'm here with Kapil and Emdar, our Director of Research and Development, who will also be participating with us today.
If you just put it in slideshow mode, it'd be great.
Yeah, we're getting there. Hold on, guys. We do this all the time. I don't know why it's not wanting to. Hold on just a second for me. This again.
And notice, Ryan, if you've got any questions, please put them in either the Q&A panel or the chat panel, and we will get to those as soon as the presentations each end.
Showing. I don't think it's showing. Give us just a second here. It's giving us fits. I'm not sure what's going on. Here we go. All right. Okay, how's that?
Might need to either duplicate your slides or swap. We're still seeing the main, your edit screen.
Hold on, I've got my technical expertise here.
Okay, then go into display settings and either duplicate slideshow or swap one of the two. Up at the top. How you just
Yeah, give us just a second. We do this day in, day out. I don't know why it's a little bit different here. Maybe
yeah, at
it's
the top of your screen, you have a thing called display settings. And if you either duplicate
normally we
slides.
do, right now we don't. Give us just a second here.
Okay.
Hold on just a second. Page. Extend.
Yeah, you blocked your monitor, that's why. You turn that off.
What's going on here, huh? This is bizarre. This again. No, it's nothing.
Yeah, because you had put the block on the monitor underneath the screen. You see a slash through your monitor on that one on the side.
I'll share for just a second. Sorry, guys.
Yeah, somebody clicked on that block monitor or blackout.
Oh, somebody clicked on the block monitor? Uh-oh,
Yeah.
That's not good.
Not us. But
I understand.
like you moused over it and accidentally turned it black. Stop showing.
All right, give us just a second.
So you couldn't see it.
I see what happened. Now you can see, let's see, hold on just a second.
Yeah, you'll have to share again.
There it is. How's that?
You
There
are
we go.
ready to go. Let's.
Woo, finally. Oh my gosh. All right. Well, thank you again. And we're going to give you a little background about PMC because you're right, Dale. A lot of folks may not know who we are and how we fit in the Toray group. We were acquired about 3.5 years ago by Toray. So as we walk through the presentation, you may have seen or heard of our materials, and I promise you that if you've got kids that are teenagers, they're probably wearing some of our materials on their feet, okay? So a little background. As you can see, Toray is a very global company, and we have a very global view of many, many industries. So we're part of this whole big conglomerate that you can see here. In pink, we have the Fibers and Textiles group. The Resin and Chemicals group is in light blue. Films is in the darker pink. Orange shows the Electronic and Information Materials group. Red is the Carbon Fiber group, which we are a part of. Purple is the Pharmaceutical and Medical group. Water treatment, this includes the RO membranes, is the darker blue. And finally, we have yellow that represents the trading companies in each one of these countries. They take care of a lot of the global trade issues that, you know, are very, very, I would say, timely right now as far as carbon fiber and moving from one country to the next. So coming back to the carbon fiber group, which is in red, Toray is the largest manufacturer of carbon fiber on Earth, and we produce vertically integrated globally. So this has really been a very advantage for us, specifically during COVID, and it's the ultimate supply chain security because we have the ability to manufacture in Asia and in the U.S. and in Europe. So if you're interested in any of these other divisions, you can feel free to reach out to us afterwards, and we'll connect you with the right people. Okay, this is our little slice of heaven for Kapil and myself. We're drilling down to our division here. We have manufacturing in Camarillo, California, which is where we're located today. This is where most of our composite sheets are made and fabrication in Guangzhou, China as well. We have representative offices in Taichung, Taiwan, and sales offices are scattered throughout the U.S., Europe, and Asia. Again, our teams have strategic locations, and this allows for smooth product development, which has been very important during COVID. I mean, I could say it was easy. We moved projects from one place to the next, but we all know this is simply not the case. It takes a great team to do great things, and we had folks working around the clock, day in, day out, on the weekends, you know, where, you know, Asia's waking up, and the U.S., we have people working from home here. We moved projects from one location to the next, and I'm happy to say that we did not cause any delays for our customers. from a project management and development standpoint, nor from a manufacturing standpoint. This is a common pyramid some of you may have seen before. It's basically laying out the world of polymers that we work in. You can see at the very top are the high temperature polymers, our division in Morgan Hill, Toray Advanced Composites works within. These are normally used in highly engineered aerospace application. And if you're looking for something like that, we're again happy to connect you with our colleagues there. We work in the bottom 2/3 of this pyramid. When we talk about the engineered thermoplastics, keep in mind we can combine woven layers with UD layers as the polymers are compatible while giving the benefit of UD efficiencies and properties with the woven cosmetics so many of our customers desire. So think about taking those unidirectional materials and having 3K or another woven layer on top. This is what our division has been known for. We offer these polymers in a number of carbon and glass options as well as hybrid options, where the combination of woven and UD can be interchanged to some extent. So some common uses. You see the nylon 6, which is our TC 910, typically used for battery covers, seat structural reinforcements. The parts are compatible as strategic reinforcements with typical polymers used, and they're easily injection overmolded for mechanical bond. So think about taking these unidirectional materials or woven materials and just using them strategically, able to injection overmold and come out with the product that you're looking for in probably the most cost-effective way. Next, we have the TC 925. This is our polycarbonate. This is widely used for consumer electronics industry and in aerospace and transportation, where fire resistant is desirable. Again, parts are compatible with typical polymers used, easy to injection overmold for mechanical bond, and used strategically. The fibers can provide strategic reinforcement all over the structure. Now we move to our PET polymer, which is our TC 940. This polymer combination with glass and carbon has been our workhorse, and it's predominantly due to the efficiency of materials for the cost-performance trade-off. We're able to achieve a multitude of aesthetics, and our customers are also latching onto this combination because they relate to the polymer being part of their water bottles, and they're using it for recyclability. Next, we move to our TC 950. This is our PMMA resin system. It's an impact modified in-house formulated acrylic resin system, and it is our proprietary formulation. This is probably what you most know our division for. It's what launched our company in the 1980s, and today we've produced in excess of 200 million parts. Yes, 200 million parts, and counting for our acrylic resin system. The polymer and woven combinations with carbon and glass, they allow us to pigment the resin and provide beautiful color options. Unlike the nylon 6, the polycarbonate, the PET, and polypropylene, where the resin systems are either black or natural, our customers enjoy the full Pantone ability of our PMMA resin system. The TC 960 polypropylene is best used for high impact and chemical resistance, and it's one of the lightest resin systems we work with. All right, here's the markets that we serve. And having a wide range of polymer and reinforcements to work with launched our division into all of these markets. It all began in the medical market in the 1980s with our proprietary PMMA acrylic resin system. The intention was to replace expensive thermoset custom orthotics with our CFRT materials. The benefit to the doctor was customization and modifications right there in the office, and it added comfort to the patient. We then went from corrective applications to protective applications in the footwear and recreation markets. And this is when we developed our high volume manufacturing part process. Making parts and this expertise came from our customers really not knowing what to do with our materials. The process is fine-tuned, and now we make millions of parts per month. We took what we learned in high volume manufacturing and applied that to the wider range of polymers we mentioned earlier to create materials, preforms, products for computer electronics, and also industrial markets. So how do we do it? The first step is to make a flat sheet laminate Then cut the parts. We normally water jet 2D nested parts. The parts could also be stamped, but the water jet provides the most cost-effective option. The water jet makes a 2D from a 2D nested product, produces high volume and high yield with almost full material utilization. This equals lower cost. Material, or what we call a skeleton left from water jet, well, Kapil's going to talk about how we're creating new products from this post-industrial scrap later in the presentation. From the water jet, you see a 2D cut part. Again, these parts are cut literally in seconds, producing millions of parts per month. Now we have a form part, which we will form either vacuum forming, matched metal tooling, and compression molding. These are formed in seconds with no post-trimming needed. The part that you're looking at there was being used as the final product, which was injection overmolded with a clear TPU. The black inside shot was the first shot into the part. In this case, this product has a tie layer. We call this our EB or EnviroBond 401, which is a TPU bonded layer. This was developed to eliminate the need for harmful solvents, used as cleaners, primers, and adhesives. So there's the final product you can see down in the lower right on the left-hand side, and the clear shot, which makes a beautiful part. The part on the right is the computer laptop case cover. This product was made a bit differently from the unidirectional tapes. This product, we've laid up the uni tape and added plugs of material where we needed it, built up for hardware attachment. This amount of detail is achievable with kitting, building materials in strategic locations on a part, and compression molding and then injection overmolding. All right, we've got two more examples here. On the left, this is an example of a compression molded ability, tape laying strategically. The photo there on the left is what we call our ant part, and it begins with just taking tape and rolling it up and then crisscrossing the tape. And through heat and pressure, we have a very defined part that has fibers consistently placed on burn-off. The photo on the right shows the kit and final product of the toe cap. The advantages of CFRT toe cap is it met all the ASTM standards for steel, but when compressed and released, the cap rebounded, so this could save your foot. And on impact, it leaves a slight dent, which the wearer could be alerted that the cap took a hit, and the footwear should be replaced. Unlike some plastic caps that crack, and you may never know that it's cracked, and then it could be tragic when the cap itself takes an additional hit. Remember earlier in the presentation, we promised to talk about our sustainability. So I'm going to invite Kapil here to cover this area of our innovation.
Thank you, Laurie. Can everybody hear me okay? All right.
Yes, we hear you.
Thank you.
Okay. So yeah, the whole idea here is as we deal with our customers, but also looking internally, one of the targets that we have set up is identifying areas where we really can be heavily sustainable and focus on zero discharge as a target. And referring back to what Laurie mentioned, the organization has already produced over a few 100 million parts, and that gives you a flavor of how much scrap we can generate in terms of the skeletons that come out of the water jet cutting process. Not only that, of course, like any business, there are also certain scrap final parts for quality reject. So what we are focusing here, me and my team, is identifying really scalable avenues for us to take the scrap that is generated, and there's a lot of work, of course, happening globally. But what is driving us here is cleaning internally ourselves of the scrap we have, but also there's a very strong market pull that we see. And some examples here that I'll be covering are based on the PMMA composite scrap, which is only one portion of what we do. And the whole idea is really to take the scrap and then convert it into a workable form. In this case, really finding a good technology that can chop it up consistently. And that has been one of the challenges we had, having a good, robust technology that can consistently give us a product that can be fed into a compounder, if you will. And then we are looking at blending it. That's where a lot of technical activities are going in identifying blends and compositions, which can give us a product that is robust enough. And in this case, the bigger driver for us was stiffness and also the elongation for certain applications. So some data is represented here, specifically sample numbers 20, 21, and 23. And through various formulations and the expertise that we have, you can see that we have been able to achieve a range of different elongations, which was the biggest driver for a particular application. And our target was in the range of 3 to 5% elongation. So point being, we are at a stage now where we have a very solid design space and we are able to optimize our formulations. And we are in the process of scaling this up for certain customers. Not only that, with the expertise that we have got some demonstration tools that allow us to do a very good show and tell to our customers, including being able to impart a textured surface on our parts. And generally speaking, the range of scrap we can deal with is about 20 to 30% on the high end right now. And so that really helps us take care of a few 10, maybe over 100 metric tons of the scrap that we have at disposal, which means that we have a very good scalable pathway to supply in large volumes to the industry. On the next page, I'm going to cover two topics at a very high level. On the left, I'm talking about the emissions reduction. I'll start at the bottom bullet in this. Where
hey, Kapil, just I appreciate if you go through these quickly with the delays we had at the start.
Yeah, sure, we'll do that. So the emissions reduction, it's the organically developed process that we have is eliminating a 30-year legacy process. And I think those of us who have seen part production in thermosets really will appreciate what that means. And in this case, of course, it is with thermoplastics. We do reactive chemistry, and we are able to eliminate 80% of VOCs from our production process. And we have a few patents that are pending right now globally. The next topic is the recycled carbon fiber. Again, I'll rush through this real quick. The whole idea is to leverage our backward integration into Toray and Toray businesses and have access to a good, robust waste stream of carbon fiber. And through that, me and my team, what we have been able to do is we have been able to demonstrate multiple pathways to create various material forms, including fibers for compounding, fibers for making very high quality non-wovens with 100% recycled fiber. And what that means is, especially for industries like automotive, where IACMI is a very big player, these are some of the opportunities where the volume supply of very high quality non-wovens, for example, can be very sustainable. And I think that said, I'll pass it on to Laurie. We just have another 1 or 2 pages.
Yeah, this is basically it, guys. So just to recap, we started out as a very small company back in the 80s. We were pioneers in CFRT. We started out with our PMMA acrylic resin system, and from there we've evolved into an organization that's able to service a number of industries across several markets.
All right, thank you, Laurie. Thank you, Kapil. Again, because of the time constraints we've got, if anybody has any questions, please put them in the chat. I put one in the chat I'd like you to address, and so if you could do that, I'd appreciate it.
Sure, we'll take a look at that.
Okay, all right, thank you. All right, we'll move on to our next speaker is Wolfgang Hinz. Wolfgang is the head of expert sales, composites, and services for Krauss-Maffei. He's coming to us from Munich. So Wolfgang, if you'd share your presentation, we'll get going.
Thank you, Dale. Can you see my screen?
Perfect, thank you.
Okay, so my name is Wolfgang, and today I want to give you a short overview about 2 latest composite technologies for lightweight serial productions. The first technology is called long fiber injection, which is a competitive technology to SMC. And the second one is called fiber form, which is a composite technology out of our thermoplastics for high volume lightweight parts. For those who don't know Krauss-Maffei, so Krauss-Maffei is a very traditional company founded in 1838. with a lot of locations around the world. We also have a subsidiary in the US, the headquarters in Munich. We have around about 5,000 employees, and you can see us on one side as a machine manufacturer for all different plastic applications, but on the other side, we are also a technology developer, and for example, in composites, we would say we are also a kind of market leader in specific areas. I want to start with the technology long fiber injection. And therefore, I have prepared a movie. We don't need the sound. So basically, this is one production line sitting at one of our customers in Germany who is using the long fiber injection machine with 2 production stations. Here we see the upper and the lower mold and 2 operators who are preparing the process. So the right guy is using air to clean the mold, and the left operator is spraying a release agent on the upper mold. You can also integrate some inserts. Here in this specific product, we are working with a thermoformed film, which is thermoformed in a previous step. We shuttle the lower mold inside the LFI spray area, where our mixing head is sitting, mounted on a robot. And then we are spraying polyurethane and chop fibers directly from the glass fiber rovings, mix it in a mixing head at a high pressure, and back inject it or back spray it on the thermoformed foil. The advantage is that you can adjust the fiber length and the fiber volume during the process. So this is really unique compared to SMC. Then you shuttle inside the press area and you close the mold completely. Here we are using very low pressures, so only 5 bar in-mold pressure. So here, for example, for such a large part, you only require a 300-ton clamping force. And while station number 1 is in the reaction process, on the left side, a new mold is shuttling in and use the spray robot. I was mentioning it's a competitive technology to SMC. So why? Because on one side, it's more economical because we have lower invest for the presses and for the tools. And on the other side, we are also lighter than SMC because we are not using many fillers, which are making the SMC parts heavy. Here you see the cleaning process, how we clean the mixing head automatically. So it's a self-cleaning process. Here you see our metering and mixing machine, which is constantly monitoring the components and the pressures. And once the reaction is finished, you open the mold. In this case, we are using aluminum molds. And you can demold the part and put it into the next step where you do the final edge milling. In this case, what you have seen here, this was a side panel of an agriculture vehicle. What is unique at the LFI technology? So basically, the base material is polyurethane, and you can, in most of the applications, it's mixed with glass fibers, but you can also use carbon fiber or natural fibers. Therefore, we are specifically developing a new carbon fiber cutting device, which will enable new products and new applications. So polyurethane with fibers, this is the standard application. What you also have seen that we are using in the spray area. You can combine it with different fillers. So you can premix it in the polyurethane to reduce the part costs, for example. You can integrate some cores, for example, honeycomb papers, aluminum honeycombs, or even foam cores inside the process to further reduce the weight or increase the performance. Or you can combine it with different surface technologies. So in the movie, you have seen a combination between LFI and the thermoform foil, but you can also combine it with an in-mold painting if you have to change the colors more often. Or you can even use synthetic leathers to achieve a premium interior part. Here you see typical parts, what our customers are producing: interior covers, engine covers, roof covers, side panels, body covers, bumpers, and so on. So as I was mentioning, the base material is polyurethane, so it's a thermoset. Typical cycle times are 3 to 15 minutes, depending on the part size. The typical production volume, where it's one of the most economical composite technologies, is between 3,000 and 50,000 pieces, so depending on the part size. And the driver is really the ratio between mechanical performance and costs. What are the USPs Krauss-Maffei can offer? So we were the inventor of this LF long fiber injection technology, and we have a 20-year technology advantage compared to our competition. You can adjust the fiber amount and the lengths during each part. And we are also the market leader here because we have the most serial production experience. Coming to the second technology called FiberForm. Here we are switching to a higher production amount, and not with thermoset. Here we are using thermoplastics. I switch off the tone again. Oh, sorry. So here you see the overview of the FiberForm cell. Here we are combining an injection molding machine made by Krauss-Maffei with automation using, in this concept, 2 industrial 6SX robots for the handling. You have a material feeding station where you store your organosheets, for example, or your intermediate composite sheets. Here we have a centering station. And the heart of the process, our patented infrared heating station. At the end, we are using conveyor belts for the quality assurance and also to move the finished parts. So when we are looking at the process, here we have a high performance screw, which is melting the thermoplastic flakes to back inject it on a preformed organosheet, for example. You can also use, for example, recycled carbon fiber and mix it inside the process. Here you see the demolding of a finished part and positioning it on a conveyor belt. And now we are starting a complete cycle. So the robot with a gripper is taking the organosheet, putting it on a centering station that we always have an accurate position in the mold. Then the second robot is coming, moving this organosheet into the infrared heating station where we are measuring the temperature and applying with infrared heat to make sure that we have an equal temperature distribution over the complete sheet in a very quick time. In the same time, the injection molding machine is positioning the mold to a position that it's almost closed. Then we are taking over the preheated sheet, preforming it, and back injecting the thermoplastic system. After that, we are removing the part and putting it on the conveyor belt. So here is the same, that we can combine it with different materials. So the standard is that you're using organosheets either with glass fiber or carbon fiber, which is a pre-consolidated organosheet which you heat up and back inject either with polyamide or with PP, for example, and you can also use short fibers. The second version, to achieve a better sound insulation, for example, is the use of natural fibers. So you can also use consolidated natural fiber thermoplastic sheets to achieve a Class A surface. You can use visible carbon fiber sheets to reduce the waste or define variable thicknesses of fiber orientations. You can produce your own sheet with the tape laying method and use this preform into the fiber form process. Or the latest development is that you are using thermoplastic pull-through rods, heated up very quickly and integrated with the fiber form process, which is the most economical method, and you only use the reinforcement in that area where you really need it. Typical applications are here, for example, most of our customers are out of the automotive industry, door panels, seat shells, lightweight carriers for the entertainment system in the car, airbag housings, or structural parts, but also armrests. What is also pretty new are underbody shields to protect the EV cars, so the electrical batteries, firewalls, and so on. So the driver is here really a high production volume and a weight reduction. Here we are using thermoplastics with a cycle time of 60 seconds per part, roundabout, and the technology is suitable for a production amount higher than 100,000 pieces per year. So less than this amount, there are also other technologies which could be more competitive. What are the USPs from Krauss-Maffei? So here we have a patented infrared heating system. We have the fastest production cycle on the market because of our unique production cell. So therefore we have the highest production output. And we are also the market leader in this technology because we have the most serial production experience. That's it from my side. Thank you very much.
Thanks, Wolfgang. I had a question. There's a question in the chat. I think it had to relate to the LFI. Is can you use carbon fiber? I think you said that you can.
Yes.
You are doing that. Yeah.
Yes, you can.
And then who in the US is using the LFI system? Are there any companies you're aware of or recommend?
Yeah, we have certain customers which are using it, but I don't want to mention any names here. So you can contact us directly, and then we can give you some names.
Okay. No question. Have you using PU? Can you use epoxy?
For the LFI process?
Yes.
No, not yet. So there is a method where we are not spraying the polyurethane, where we are laying the epoxy resin on top of the fibers, but the name is another technology. We call it wet molding.
Right, wet compression molding. I've seen that in practice at BMW. Yep.
Yeah.
Yep. Okay. You talked about using calcium carbonate, things like that. Any work done in using glass bubbles to lower the density, like you get low density SMC? The glass
Yes,
microspheres.
yes. There were some developments ongoing, not in the LFI technology. It was in another technology, but it's in general it's possible. Yeah, we were working on this for several years. The problem at the beginning was to get the pressure-resistant glass microspheres, but we have solved this, and it's available. Yes.
Okay. All right. Thank you.
You're welcome.
So our final speaker is Peter Hedger Jr. Peter is the Vice President of Business Development for the Composite Applications Group. And so, as I said, we move from materials to process to now applications. And you've seen some of these applications before out there, but he's going to give us a little more insight into it. Peter, all yours.
Thank you, Dale. I appreciate it. And to everybody here, appreciate you guys attending. We do appreciate IACMI for putting this event on. I think it's very informative for the general public and folks who are either learning more about composites or they're in the composites industry and trying to get an edge. You'll see a little bit of similarity between our catchphrase. Instead of convene, connect, and catalyze, we have connect, collaborate, and commercialize. So there's a lot of C's there. I hope you'll forgive our messaging similarities there. But what we do at Composite Applications Group is we help technology similar to the ones that you're seeing here connect with OEMs or folks or companies that typically don't produce composite parts or composite things. And we help them connect to the technologies necessary to get there. And I'm going to share a little bit about some of those connections that we've made. Let's see if I can get this thing to cycle through. There we go. There's a quote here from Ken Huck. He was the partner that we had with Trinity Rail. We'll dive a little bit more into detail on Trinity Rail in a couple slides here, but that really sums up, and thanks to Ken for that quote. It really sums up really the crux of what we do. Because too often what you're going to find is folks that are companies that are manufacturing with parts that they know or materials that they know, whether it be metals or thermoplastics or wood or other materials. They have a hard time kind of bridging the gap between going down to their current supply chain and picking up the materials they need to get across the finish line, because those current supply chains don't work for traditional composite materials. And what we've been approached with so often is the desire to increase that at a rapid pace. And that's really what we've done. So we use the connections that we have to form a team that's non-competitive, and around that team and around those technologies, we collaborate to deliver to the OEM what they're looking for in the time frame that they're looking for. And the ultimate goal of all of our projects is while there is research and development, there is testing, the ultimate goal is that we're commercializing, and that benefits the OEM and all of the technology partners involved. So one of the things too that we did, as well as obviously everybody in the US is aware that the infrastructure is a big deal. If you've driven on any of our interstate systems, you realize that the bridges and the roads are in desperate need of upkeep and repair. And being aware of that, and also being aware of the fact that composites is not necessarily new to the infrastructure world, we decided to take it a step further. And what you see here is our effort with IACMI and the University of Tennessee to actually install a composite bridge deck. And that was used with structural composites, Prisma preform. So it's the backbone of this technology. You can see it in the picture in the top right, those white caps there. Those are actually extending the length of the bridge deck. And those white caps are that's actually a polyurethane foam, and that forms a geometric shape. That geometric shape provided the strength of the composite. It's wrapped in fiberglass. In this case, it doesn't necessarily have to be fiberglass, but in this case, it was fiberglass. And on the top is Structural's patented co-cure technology, and that's a blended polyurethane polyester. And that provided the wear surface that you see there. And in the bottom right, you can see the bridge is finished. This isn't a crazy big bridge, right? This isn't something it's not an interstate bridge. This is a small rural bridge. But this bridge is critical for the folks that live in that area to be able to cross that creek. So while it might not be an impressive size, it is a critical bridge for the folks to be able to commute in and out of their rural village or rural towns and rural houses and properties and such. And the interesting thing here, you can see that small forklift. That's the entire bridge deck right there. That was installed in about 6 hours. And that kind of throughput potential for composites, where it's manufactured off-site, brought to the site, and installed within 6 hours, that allows the downtime of many of your companies many of your municipalities who are struggling with either supply chain and or getting people to the site, tearing the road apart, tearing the bridge apart, and then having to rebuild it with traditional materials. It takes a long time. And so people are having to be rerouted. It disrupts the economics of it. And it's just not a helpful way to be able to get people back up and running within those areas. And so this is a project that we're continuing to scale. You'll see more development in this area in the future. It should hit several national headlines as it continues to grow. Another one is the 53-foot composite refrigerated trailer. So this project really was the genesis of the Composite Applications Group. Our founder, Jeff McKay, actually was approached by Wabash, and you'll have to forgive me for the dates, but it was, I believe, 2016 or 2013. I'm not sure when, but it was a while ago. And what happened was Wabash approached Jeff McKay and said, do you think that you can convert a traditional trailer into a composite trailer? And Jeff said, absolutely. And so after he promised that, he then had to go and figure out how to deliver. And that is where Composite Applications Group came from. This trailer, you can see the benefits here. It's 30% thermally efficient, improvement over the thermal efficiencies they had previously with their technology, 25% lighter. And this is all the stuff you're going to hear from composites, right? We're lighter, we're stronger, we're going to be better thermally efficient. But really, if you look at that bullet that says cost neutral, that cost neutral compared to current construction, that's critical. Because Wabash is able to produce these trailers at a rate and a cost that was competitive to their traditional trailers, and that was unheard of, right? Composites are typically a more premium material because it offers premium benefits. Now, if you can capture those premium benefits without a premium price, then you're really in a really unique situation. And the reason they were able to do that is because when we collaborated with Wabash, we're not looking to say, okay, we're going to make a fully composite trailer. What we're looking at is let's take the entire project and figure out where composites make sense. We're also not looking at it and saying, okay, let's replace your bumper with composites. It's a difficult scenario when trying to convert companies that are producing something out of a non-composite material and then saying, okay, let's just replace this one part because it has ramifications for the rest of the structure. And then you can't just necessarily go in and say, well, let's do the whole thing out of composites, because what you end up doing is you have to rely on exquisite or interesting or more high-performing materials, which increases the cost. What we were able to do is take a hybrid approach and say, where do composites fit best? And in this structure, you can see that all of the wall panels and the floor system, the skirts, those are all composite, fully composite. And what that did is it reduced the materials. You're going to see this duplicated with Trinity, but it reduced the SKUs. So there wasn't as many materials needed to assemble it. It increased the throughput. So they were able to produce it at a more rapid time frame. And a lot of those soft costs, that's what helped drop the price down and make composites more affordable, because there's no panels here. It's one solid sheet, one solid panel that goes down the length of the trailer. That's important. That's important to note. And the production actually began in 2016, and we won the award for CAMX in 2017. And I'm proud to say that with the Trinity project, which we're talking about now, the Trinity project, we actually won the 2021 CAMX award. So we're shooting 1,000%, 2 for 2, and being able to not just provide innovation, but provide innovation to companies that need the innovation. They can commercialize that. So this is what I was talking about as far as the structure of how we work. We focus around the OEM. We find a composite technology like structural composites, and we surround that structural composites with the supply chain needed to bring that technology to market for the OEM. So the structural composite Prisma beam that you saw on the bridge, that is also the backbone of that trailer. And that's because it's a polyurethane foam, which has a high insulation value, but it needed to be surrounded with glass, it needed to be surrounded with resins, and it needed to be surrounded with application equipment in order to make that possible. That's not something that is a supply chain familiar to Wabash. At least it wasn't when we began the project. But by partnering and collaborating with these companies, we were able to bring that about and do it in a way that Wabash is now fully invested into the composites technology. And if you follow Wabash at all on the stock exchange, you'll see that they're doubling down on that investment. They believe that composites are the way of the future for the trailer industry, and they're going to continue to make investments to see that succeed. Here's the Trinity rail car. So Trinity is another partner that we've worked with. And you can see some of the benefits. Again, you're dropping weight, you're dropping your price and part count by a ton. And then the important thing too is if you're familiar with rail cars, you're like, well, okay, rail cars are huge. They're incredibly heavy. Well, 4,500 pounds, like that's, you know, a couple bags of grain or a couple totes, right? That doesn't make a lot of sense. But if you multiply that 4,500 pounds times the length of an entire train, you're going to get a significant decrease in the energy needed to transport that material from one place to another. And it increases the ability to add more weight and not have to and add more value to it. Because sometimes what happens when you're transporting, and people that are in logistics understand this, sometimes you'll cube out before you weigh out. So you have excess, or sometimes you'll weigh out before you cube out. I apologize. It's the reverse. So by weighing out, you still have space that you're shipping, and that's not helpful to the shipper, the end user of Trinity Rail, or the end user of Wabash. By using composite materials, they can ship more for the same amount of energy or the same amount of cost. However, they're making that metrics viable. And so this is some of the details on that. You can see that if you remember those caps that I pointed out in the bridge, you can see that kind of construction on the bottom of the floor here. On the left-hand side, you see the Prisma. That's the yellow pale color. That's the Prisma foam. And on the outside, you have a fiberglass that wraps around it. And you can see here on the right-hand side, I don't have the picture here that shows I believe it comes up in a second, that shows the reduction in parts. But there's a drastic reduction in the amount of fasteners needed, the amount of connection points needed, because the amount of material that's going on there has been reduced. And that's critical in order to be able to achieve a commercial path. And it's, again, too, you'll also notice that there's aluminum used here. We're not saying that this entire structure needs to be made out of composites, because that's not necessarily functional, because then you're going to start leaning into heavier or more expensive materials, and the project becomes, the commercial path begins to get murky when you say everything has to be out of composites. And for those of you that are listening, I took a glance at the list of folks that are participating. A lot of you guys are composites professionals and have been in the industry a long time, and we're very fond of committing and overcommitting and claiming a lot of really interesting things. And what that ends up doing is putting us into a corner where we become enemies with some of these other materials as an industry. And that's, in cases like this, it needs to be more collaborative. It needs to be a true composite, right? You're blending a fiber reinforced thermal set or thermoplastic material with something that's more traditional like aluminum or steel. And that's really where you're going to find the most success. And that's really where we're finding the most success, because then you can take the places where you're looking for the modulus of steel or the modulus of aluminum and apply it for a lower cost than you would to match that modulus with a carbon fiber, or to beat that modulus with a carbon fiber, because you really want to put the parts and the components together where they're going to show the most strength. And that is only achieved through collaboration. You can't just kind of throw all the spaghetti at the wall and hope it sticks. It has to be achieved through collaboration. And that's something that we pride ourselves on. So the companies that we partner with, they're non-competitive. And because of that non-competitive nature, people tend to be more engaging with their conversation, and then their collaboration becomes more robust. Here's some pictures of the inside. You can see that Prisma technology on the bottom right, on the right-hand side. That's the floor that was at the CAMX show. If you were at the CAMX show, you probably had a chance, if you went to the award section, to see that floor being showcased. You can see the corrugated aluminum is being bonded to that composite structure. And on top, you have the tread plate, and that's being fastened mechanically. So you have a combination of chemical fastening and mechanical fastening, and it's all being done with composites right there in the mix. And the advantages that Trinity has is that they're able to move things around a little more easily. It's a lot lighter weight. They can gain advantages in the airflow. And it's one singular long floor. There's no joints in that floor, and that improves the structural integrity of the entire rail car. Okay, great. Here's the picture I was referencing earlier. You can see the previous design. You see all those parts. Those parts, that's a tremendous amount of material that's being used. On the new design, because of the continuous panel, continuous design of composites, it lends itself to reducing the assembly hours, and it also reduces the part count. And that in turn, even though composites are lighter, because you're able to reduce the part count, it's significantly lighter. It's just not a apples to apples comparison. You're not just comparing the weight of a fiberglass part that's replacing the weight of a steel part. That's why you can't always look at like a single part replacement, because if I was just to go in there and replace one of those pieces on the left-hand side, yes, you're going to get a weight savings individually, but I'm not reducing the amount of parts used. I'm not necessarily reducing the amount of labor. There has to be a full hybrid design that takes into account the strengths of composite materials, the strengths of fiberglass and resin, the strengths of that particular resin. And you guys that are in the composites industry, you know how complicated that can get when you try to determine what type of resin marries with what type of glass, what is the sizing on that glass or fiber. Is it going to be a biofiber? Is it going to be a bioresin? What are the additives inside that resin to accentuate some of the strengths and characteristics needed? It's a very complicated supply chain. So I can't just go down to the local hardware store and pick up some 440 stainless and call it a day. I have to sit down with my engineers. I have to sit down with the team. I have to collaborate on what's going to make this successful and what are the different components that need to be applied here in order to achieve that new design, in order to get a hybrid model that lends itself to the strengths of both materials, from the composites and the metallics or the thermoplastics or the wood fibers or whatever it is that they're assembling the structure with. And so back to what we do. When I talk about collaboration, here's a brief snippet of some of the companies that we work with. Toray obviously was on earlier. We work very robustly with Zoltech. I think I saw a couple folks from Zoltech on here. We appreciate that partnership. And it really takes this entire team, and this is just one glimpse of the supply chain, but it takes this entire team to find the solutions needed for companies like Trinity, like Wabash, like your local DOT, to find those solutions needed to be able to bring commercialization to the table. And each one of these companies has had a lot of opportunity to be able to work with us to provide those solutions. And you see it's a mix of what we would consider OEMs and technologies. And the interesting thing too is that a lot of these companies end up finding projects they can do together in the midst of bringing solutions to those OEMs. So that's really what we do. I didn't see any questions pop up in chat, Dale, but that's the conclusion of my presentation. I hope that was helpful. Again, this is something that we work really well and really appreciate the form and function of IACMI, because we're real parallel in how we approach things, and being able to work with IACMI and see some of the work that they've been doing and help them on some of the projects that they've been doing has been excellent. So
Thank you, Peter. And again, I want to say we're at 1 o'clock, so we want to keep it timely here and let everybody get on to the rest of your week. I want to again thank our presenters, Laurie, Wolfgang, and Peter. Again, this presentation will be available in a recorded fashion within a couple of days on our website. And also, just feel if you want to reach out to any of our presenters, just get a hold of me or events at iacmi.org, and we will connect you up. So again, thanks to all of you, and we will see you next month on March 21st.
Thanks, Dale.
Thank you, everybody.